All right, welcome. Today, we're diving into something that sounds, well, a little wild. What if the process of getting oil out of the ground could actually help our climate? Yeah, I know, it sounds like a total paradox. So let's get into how that could possibly work.
So just imagine for a second, what if we could take this huge industrial byproduct, carbon dioxide, and flip the script? Turn it from this massive climate liability into a genuinely valuable asset. I know, it sounds almost too good to be true, but that's the core idea we're going to unpack right now.
Okay, so first things first, let's set the stage with the problem. Our industries, they generate just enormous amounts of CO2. And figuring out what to do with all that stuff, that's easily one of the biggest challenges we're facing today. So to deal with this, right, the whole world is on this urgent hunt for ways to capture and store that carbon. You've probably heard of it, CCS, or carbon capture and storage. The goal is pretty simple. Grab the CO2 before it ever gets into the atmosphere and lock it away somewhere safe. But, and this is the big question, where exactly do you put it? And that question leads us to a really surprising potential answer, coming from an industry you might not expect at all. It's called CO2 Enhanced Oil Recovery, or, CO2 EOR for short. So, what in the world is it? Well, to put it simply, CO2 EOR is all about taking captured carbon dioxide and injecting it deep, deep underground into oil fields that are already there. And what that does is it helps push out more oil that was kind of stuck and unreachable before. Okay, and here it is, the million-dollar question. This feels like a complete paradox, doesn't it? I mean, how can a technique that's designed to produce more fossil fuel possibly be a good thing for the climate? Well, the secret, the real trick, is all about what happens to that CO2 after it's been injected.
So to really get it, we've got to look at the mechanics of this thing. Because the real environmental benefit here, it isn't actually about the oil. It's about permanently trapping that carbon deep, deep underground.
So here's how the whole process breaks down, step by step. First, you capture CO2 from some industrial source like a power plant. Then, you transport it over to an oil field and inject it into the reservoir. Now, this does help produce more oil, yeah, but, and listen, this is the most critical part, a huge chunk of that CO2 gets permanently trapped down there in the rock.
And get this isn't just some happy little side effect. No, this is the entire environmental argument for the technology. The main benefit here is, and I'm quoting, the permanent sequestration of carbon dioxide in geological formations. In other words, that CO2 doesn't just, vanish. It gets locked away. For good.
All right, so the theory seems to make sense, right? But the real question is, does it actually work out in practice? Let's dive into the numbers and see what the real-world impact looks like. So when you look at the whole shebang, the entire life cycle of this process, from capturing the CO2 all the way to producing and then burning the oil, what's the final score? What's the net result for the climate? The result is, well, it's pretty striking. This number you're seeing, negative 63%, that represents a net emissions reduction for every single barrel of oil that's produced this way. And that's absolutely the crucial point here. It means that for every bit of carbon that gets released when you burn the oil, a lot more carbon is being permanently locked away underground. It's actually carbon negative. Okay, so a 63% reduction per barrel, that's really impressive. But how much CO2 are we talking about here? How much could we actually store this way? Let's zoom out from just one barrel to the entire planet. And wow, this is where the sheer scale of this just becomes mind-boggling. The International Energy Agency, the IEA, they estimate that the oil reservoirs we already have could store a staggering 140 billion tons of CO2. Let me just say that again, 140 billion tons. To put that into perspective, that's like wiping out several years of our total global emissions. We are talking about a massive, massive potential carbon sink, basically just sitting there waiting. But wait, there's more. The potential benefits don't actually stop with just trapping CO2. There are some other environmental pluses we should look at too. For example, another key advantage is water. See, when you compare it to other methods like thermal recovery, where you're using just huge amounts of water to make steam, CO2 EOR uses way, way less. And in a world where we're all getting more and more worried about water scarcity, that's a really big deal. So, let's just sum this all up, shall we? First, the process permanently locks away industrial CO2. Second, because you're getting more out of the fields you already have, it could reduce the pressure to go drill in new, more sensitive places. And third, like we just saw, it uses a lot less water than some of the alternatives. It's a pretty compelling list.
So all of this leaves us with a really fascinating question to think about, doesn't it? Could one of the most effective tools for building a more sustainable energy future actually be hidden inside our industrial past? It's a powerful idea for sure, one that completely turns the whole problem of pollution on its head. Thanks for joining me for this one.